ladies and gentlemen. It's an honour and a privilege to be able to give the opening address at this St George's House consultation, the first of 3 consultations on the subject of climate change. This is the round tower at Windsor Castle. I can see this from my bedroom window in Windsor, and it's 800 years old, and it's not round, it's actually oval. I'd like to start by thanking Canon Houston Finlay for allowing me to help organise these consultations, and I'd particularly like to thank Gary and his support staff for their sterling efforts in getting out invitations to speakers and delegates in such a short timescale. When I said to Gary in December last year that I was hoping to organise seminars in March and April, he said, "You do mean 2013, I hope?" And I said, "No, Gary, 2012. Timing is everything, and this must be the year to organise the consultations." In addition to these consultations, the charity that I helped to found, Help Rescue the Planet, is organising a conference at the Royal Institute of British Architects in May of this year, from May 7 to 11. Everybody here will receive an invite to that event, and in fact they put out the programmes. Well, firstly, who am I? Well, by profession I'm a consultant dermatologist. I was director of the skin tuber unit at the St John's Institute of Dermatology, located at St Thomas's Hospital, for 10 years. I retired from the NHS in 2008 with over 200 peer-reviewed publications, mainly on the subject of melanoma and lymphoma affecting the skin. However, that is not why we're here today. During the 1980s, I campaigned on environmental issues for a period of about 8 years, until my first wife, Annie, developed breast cancer and I had to stop. During that time, I was involved with 4 campaigns, all of which impinged directly on human health and the environment. CLEAR, the campaign for lead-free air, was run by Des Wilson from 1981 to 83, and I was the medical scientific advisor. We also got involved in a campaign to tighten vehicle emissions, and we were responsible for getting catalytic converters fitted to motor vehicles in the European Union. I was also involved in a campaign to tighten standards of exposure to ionising radiation in the nuclear industry, run by Stuart Boyle from 85 to 87. He was the energy campaigner at Friends of the Earth. And finally, I got involved in the campaign to save the ozone layer and ban CFCs, run by Friends of the Earth and their then director, Jonathan Porritt, from 88 to 89. So we were very successful. We won all 4 campaigns in the teeth of opposition from the industries concerned and against the wishes of a Conservative government with Maggie Thatcher at its head. Now, I have to say that I think the fact that Maggie Thatcher had a chemistry degree from Oxford had a lot to do with the success of the campaign, because she had the scientific rigour to understand the strength of the arguments that we were putting forward. In order to buttress these campaigns, in order, if you like, to provide a scientific bedrock from which the campaigns could operate, I organised 3 international conferences in London and subsequently published the proceedings. The first was this book, Lead versus Health, Sources and Effects of Low-Level Lead Exposure, published by John Wiley in 83 and co-edited with Sir Michael Rutter, Professor of Child Psychiatry at the Institute of Psychiatry. That conference was held at RIBA, the Royal Institute of British Architects. The second book was Radiation and Health, Biological Effects of Low-Level Exposure to Ionising Radiation, which I co-edited with Sir Richard Southwood, who was Professor of Zoology at Oxford, former Chair of the Royal Commission on Environmental Pollution, but more importantly at the time of writing, Chair of the National Radiological Protection Board. Finally, Ozone Depletion, Health Environmental Consequences, published again by John Wiley in 89, co-edited with Professor Tom Wigley, who at that time was head of the Climatic Research Unit at the University of East Anglia. And that, of course, should ring some bells, as it was the same unit that was targeted, one assumes, by the Russian Secret Service, who hacked into the emails at East Anglia and then released them in an attempt to sabotage the climate change conference in Copenhagen in December 2009. And here we are at the Ozone Conference in 88. On my left, just peeking into shot, is John Pyle. Joe Farman's on my left, the man who first discovered the ozone hole over Antarctica in 83 using ground-up observations. And on my right is a younger Bob Watson, sitting in the middle, who was then head of satellite monitoring at NASA. And he confirmed Joe's observations using space-down observations. Now, it's quite relevant that when we organised the Ozone Conference, we had a section on climate change. The reason for that was that CFCs that deplete stratospheric ozone are also powerful greenhouse gases, and the solution that the industry came up with was to substitute CFCs with HCFCs and HFCs. They, of course, do not deplete ozone, but as we warned at the time, they are still powerful greenhouse gases and are not therefore suitable substitutes. The government of the day accepted our advice on CFCs, but sadly ignored it on the substitutes, and today we still have a major problem with HCFCs and HFCs because they're still in widespread use. I went to see John Pyle again recently in Cambridge, and I talked about how it was that these substitutes were still being used almost a quarter of a century later. And he told me that you have to realise what happens when you go to an intergovernmental meeting where these issues are discussed. First of all, the scientists are only allowed to present the science. They're not allowed to say what they think ought to happen. It's a bit like diagnosing melanoma and they're not telling the patient what to do about it. That is left to people called politicians. Second, if you're discussing the Montreal Protocol to ban CFCs, you're not allowed to discuss the Kyoto Protocol in the same room. So if you bring up the fact that the global warming potential of HCFCs and HFCs when you're discussing ozone depletion, the Chinese say, wrong protocol, not allowed to discuss. Anyway, back in '88, when we held the conference at RIBA, the person who I invited to chair the session on climate change was Sir John Maddox, who was then doing his second stint as editor of Nature. He was known to be quite pro-nuclear, so I was slightly anxious about inviting him to chair this session. However, I didn't need to worry, as he gave what I regard as one of the most far-sighted and perceptive statements on climate change. And I'm going to quote it to you. You don't need to write this down because it's all on the website, helprescuetheplanet.com. So Maddox spoke as follows, and this is '88, remember. Before introducing the first speaker, I'd like to say a few words about the subject of this afternoon's session, global warming. I wish to clarify my own position on this issue, not least because in the past I have sometimes been accused of being less than friendly to environmentalists and the issues they espouse. However, the greenhouse effect is an issue that we ignore at our peril. Certainly it is a field in which there are many uncertainties which are unlikely to be resolved quickly. Even so, it is exceedingly unlikely that the accumulation of carbon dioxide and other gases in the atmosphere can continue as it is at present, without at some point there being climatic change, the end point of which may be the melting of the ice caps. It is my opinion that this prospect is so serious that whatever the uncertainties in the scientific predictions, it is essential soon to work out a framework in which it will be possible at some point in the future to control the way in which carbon dioxide and other gases are allowed to accumulate in the atmosphere. In many ways, the Montreal Protocol is a valuable precedent for the kind of convention that would in due course have to deal with greenhouse gases. Obviously, the problem of global warming has much greater implications economically. Even so, despite the uncertainties, it is by no means too soon to begin embarking now on the negotiations and the kind of agreements that will be necessary to regulate the greenhouse problem. Of course, this may prove quite difficult. In my view, Maddox's only error was to underestimate the difficulties that would be encountered persuading countries to sign, particularly the big emitters such as the US and China, and those with huge vested interests in the continued burning of fossil fuels such as Canada, Saudi Arabia, and the Gulf states. However, international negotiations began well, and in '92 the Earth Summit in Rio published the following declaration by the participating countries, which was almost all the countries. The ultimate objective of this convention is the stabilization of greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. However, this agreement was never implemented. Despite the Kyoto Protocol and the best efforts of the UN, annual emissions of carbon dioxide have risen 49% since 1990, the baseline year for the Earth Summit. By any standards, that is a spectacular political failure. The deal recently thrashed out at the UN conference, COP17 in Durban, South Africa in December, allows the major polluters, China, the US and India, to continue emitting carbon without any restrictions whatsoever until 2020 at the earliest, by which time it will be game over and irreversible climate change will be unavoidable. And as Maddox clearly foresaw, when the Greenland ice sheet melts, world sea levels will rise by 7 meters, and when the Western Antarctic ice sheet melts, sea levels will go up by a further 6 meters. 13 meters is 45 feet, and Windsor Castle is only 50 feet above sea level. Even Nigel Lawson will notice that. In retrospect, it was possibly overambitious of the United Nations to try and reach unanimous agreement involving 194 nation-states on legally binding measures to mitigate climate change. The Montreal Protocol was successful because readily available substitutes for CFCs were available. The situation with climate change is significantly more complex by an order of magnitude. Even so, the alternative technologies are there. It just requires political will for them to be implemented, and any international agreement must allow individual countries to achieve their reduced carbon target by whatever means they deem appropriate for their country. Science has taught us about the complexity and the resilience of the planet, but also the vulnerability of individual species. Darwin gave us a blueprint for how life on Earth has evolved, even though the right wing in America seemed to have enormous difficulty with the concept of evolution. It is unlikely that any species is immortal, and that includes man. Even so, there is no need for any species to commit suicide, and that is what seems to be happening with global warming. What do we know in terms of truly fundamental facts? Well, we know the circumference of the Earth. It was discovered in 270 BC by a Greek, Eratosthenes, living in Egypt. How did he do it? Well, it was very simple, really, but it was also rather brilliant. Eratosthenes found a well in southern Egypt, which was located exactly over what we now call the Tropic of Cancer. That meant that on Midsummer's Day at noon, the sun shone directly down the well. He simultaneously put a vertical staff in the ground in Alexandria, and he measured the angle that the sun's shadow made with the staff. The result was 7.5 degrees. The distance between Alexandria and the well was 5,000 stads, so the circumference of the Earth was 5,000 stads times 360 over 7.5. The result he came up with was about 40,000 kilometres, which is very close to present-day estimates. The second important fact is that the Earth is not the centre of the universe or even the solar system. We now know that the Earth goes around the Sun, not the other way around. Actually, the Greeks knew that. It was called the Solian version of the solar system, but it was not until Copernicus and Galileo started observing and writing that the Solian view was vindicated and the Ptolemaic version was rejected. Here we have a page from Galileo's notebook, December 1609. And he was looking through his telescope at Jupiter, and he saw these little dots going around Jupiter, and he realized that Jupiter had 4 moons and that not everything in the solar system was going around the Earth. Just a single page from a notebook changed man's version of himself. The third thing we know about the Earth is its age. We know this because of a remarkable man called Clare Patterson, who I think deserves to be recognized as the most important scientist of the 20th century, along with Albert Einstein. Certainly he was one of the greatest researchers the world has ever produced. He worked initially on the Manhattan Project. He was an expert in isotope dilution mass spectrometry, and his job was to separate uranium-238 and uranium-235, the fissile material used in the bombs. He was horrified by what happened at Hiroshima and Nagasaki, and he devoted the rest of his life to research that would enlighten or improve man's understanding of the planet. The first task he was given was to date the age of the Earth using lead isotopes. And he did this by comparing the amount of lead-206 and 207 in an iron meteorite, which he took as the baseline age of the solar system. And he then did the same measurements in a sample of rodden rock from the Earth's mantle. The lead isotopes in modern rock result from the radioactive decay of uranium isotopes, which are abundant in the Earth's mantle. There are no uranium isotopes in an iron meteorite, so the lead content represents the amount of lead present at the birth of the solar system. Patterson already knew the disintegration constants for uranium-238 and 235, what we now call the radioactive half-life. So by comparing the amount of lead-206 and 207 in these two samples, as he put it, blip, out came the age of the Earth. And here is the formula that Patterson used. It's not quite as straightforward as E equals mc squared, but it is just as Earth-changing. Except it wasn't that easy. The lead isotopes in the iron meteorite were present in minute quantities so small they were overwhelmed by the lead contaminating Patterson's laboratory. Lead from petrol, lead in paint, lead in dust, lead used in the manufacture of glass bottles, laboratory glassware, lead in the water supply. All these sources of lead had to be eliminated completely before Patterson could do the crucial experiment. He had to build a lead-free environment from scratch, and it took him 7 years of meticulous trial and error before he was able to prepare his samples. I'm now going to quote from the book by Sharon McGrain called Prometheans in the Lab. By 1953, Patterson finally had enough super clean samples of primordial lead to calculate Earth's age. He took his precious samples to the mass spectrograph at Argonne National Laboratory, located in the midst of cornfields outside Chicago. As he worked late into the night, the laboratory emptied and fell silent. When he finished his experiment and went outside, he knew after 7 years that meteorites, the Earth and our solar system are all 4.5 billion years old. When I met Patterson, I asked him what that felt like, and he said, well, I went outside and I looked up at the stars and I looked down at the Earth and I said to myself, I know how old you are. What's more, I'm the only man in the history of the world who knows how old you are. And that felt pretty special. Hang on. Oh, I missed out something. There was a photograph of me and Patterson. No, never mind. Once Patterson had his ultra-clean laboratory, of course, he was then in a position to measure lead levels in pre-industrial samples, and he was able to show first that lead levels in the environment have gone up exponentially since the introduction of leaded gasoline in the 1920s. Note the similarity between this figure, lead levels in Greenland ice core samples, and temperature changes over the past 3 millennia. It's another hockey stick. Second, Patterson was able to show that modern man was very heavily contaminated with lead. Here we have what is known as Patterson's measles diagram. The lead burden of a pre-technological person, as measured in skeletal remains from an ancient burial chamber in Peru, is represented on the left by 1 dot. A lead-poisoned individual with clinical lead poisoning is represented by 2,000 dots on the right. And a typical person living in 20th century America or the UK, their lead burden is represented by 500 dots. For no other toxin in the history of mankind has there been such a narrow gap between what is known to be typical and what is known to be toxic. So who was the greatest scientist of the 20th century? Well, you cannot really compare Patterson and Einstein, because Einstein was like Mozart and Patterson was like Beethoven. One was a genius who created magic formulae out of his head and then wrote it down. The other, an obsessional researcher who meticulously worked away at the task in hand until he came up with the truth. Patterson never received the Nobel Prize, and I suspect that Einstein did, because his 1905 formula, E equals mc squared, is more memorable than Claire Patterson's formula for the age of the Earth. However, today I would like to reverse Einstein's formula to produce the Russell-Jones variant, mc squared equals E, where m is multitude, as in world population, c squared is carbon emissions per head of population per annum, carbon per capita, and E stands for extinction of species, or if you don't worry about plants and animals, it stands for the end of human civilization as we know it. If world sea levels rise by 45 feet, that is bye-bye to London and bye-bye New York. It would also mean bye-bye San Francisco and bye-bye New Orleans, and even Fox News would notice that. It would also mean bye-bye Holland, Belgium and the European Parliament. At the UN Conference on Climate Change in Durban, South Africa, that took place in December 2011, the conference agreed that mandatory controls on emissions of CO2 would be agreed by 2015 and would take effect in 2020. That is a step back from what was agreed in Rio in '92. Currently, China contributes 24% of world CO2 emissions, United States contributes 16%, India 10%. So 50% of CO2 emissions worldwide are completely uncontrolled, and in the case of China and India, completely out of control. China is pushing for a renewable target of 15% by 2020, but is also building 1 new coal-fired power station every week. When Chris Huhne came back from the Durban summit, he said it was a triumph for European diplomacy. Maybe. From a political point of view, it was a shambles, and from the point of view of the environment, it was an unmitigated disaster. Annual carbon emissions are now 49% higher than 1990, the baseline year for Kyoto, and emissions are rising by 5% per annum. This is only a triumph if your name is Nigel Lawson or Chris Booker. So why are we here today? Well, we're here to talk about science, and we study science to better understand the nature of things, and we do that because we want to make the world a better place. Claire Patterson put it more profoundly. Best scientists lack the comfort of peers. Their science is always at first incredible, even though later it teaches more. Why do they struggle so? Because in each discovery of new knowledge lies an awareness of the beauty and worth of human life, which enslaves them as guardians of human destiny. To me, it's about the people that we love and the gift of children. This is my wife, Nina, and this is my youngest daughter, Lily, singing at St. George's School, just below here at Windsor Castle. There are no words to describe the feelings that are generated when you realise that the future security of your child is under threat. You have to be a parent to truly comprehend that, and if you are a parent, then no words are necessary. This consultation will deal with the facts about climate change. How quickly is the atmosphere warming? What can we expect in terms of temperature rises and sea level rises over the next 100 years? Tomorrow we will talk about the health effects of climate change, nanotechnology and press coverage. I'd like to finish now and hand over to some rather more distinguished speakers than me. Ladies and gentlemen, thank you very much.